and welcome back to another stream where we once again work on Kast. All right. So yesterday I was doing something, and at the end of the stream I realized that I actually broke some advent code. Not the exactly the advent of code, but an extra community advent of code puzzle solution was broken by Liquid Cake. So I want to make sure that that keeps working. Right. So we do that like cast test on the example liquid cake, right? So it's trying to test a thing, and there is an inference error, even although there is actually no inference error that is supposed to happen. The inference error says that empty is not empty, even although empty exactly looks like empty, right? So let's figure it out. So we have field inner. And that is a value empty, is not equal to this value empty. Because these are values. Value empty inner. The field visited states specifically in this code somewhere. So let's open Liquid Cake solution here. So visited states. All right. So visited states is a thing which is okay. I see. So we have part 2 being a module. So this is a constant, means that this is available at compile time, and we evaluate a thing. Hello, Nigel. Inside of it, which is evaluated at compile time. So we have a constant, which is mutable, by the way, which are going to mutate this at runtime. Hello, Nigel. I didn't even start doing anything yet. I'm just trying to fix the advent of code that I broke. I mean, I am assuming that I broke it yesterday. We can actually see if I broke it yesterday or maybe even earlier. I guess I can see git log. I'm pretty sure that I broke it yesterday, though. Let's check out a random commit then. Yeah, it seems like it is working here. So it was yesterday for sure. Let's do bisecting to make it sure. So this is the first bad commit. Use comp time in char module, right? This is where I introduced the eval const. But the difference is how do I do the const let now compared to before. Right, so it should be, yeah, over here. We do the const let. So previously, here, I just said that I evaluate this thing directly, but now I do evaluate this like this. Even although, if I say async false, it should literally be equal to this. But the difference is that we do evaluate it directly like this without any async, but we are also uniting it with a new not inferred value of this type. So that's the difference, right? We basically, so the idea is that if I create a new not inferred value and then unite it with anything, that it should always be united properly, right? But we see that this is not true, which is the bug. Right? Yeah. So I guess there is maybe actually so the way it's happening, git status. Am I back to main after bisecting? No, git bisect reset, I guess. Git status. Yeah, I'm on main. Okay, good. So so let's see here. Let's go to test. And do something like this, right? So what is the type of M? This says test.m. Okay. Because this, so when we create a module, this creates a named type, and the name is equal to the name that we're assigning it to, basically. Right, so we don't see the actual definition of it. I want to see the definition sometimes, specifically when I am hovering on the definition itself, I guess, but I don't. Let's do a temporary change in the printing. Type tuple. Or like print optionally. What's my drink today? I'm just drinking coffee. I just woke up. So if I restart the language server right now, we're going to see the actual thing, right? So M is a module where we have a field +1, which is a function from int into int, right? Yeah. So when we evaluate this constant and assign it to this variable, before we do this, we first assign this value now to the new not inferred value, right? So we do it in 2 steps, basically. We say something like this, that m is equal to underscore, and then we say like async, basically m is equal to this, right? So that's how the language works, I guess. So we can use m directly already without waiting for this to finish in other places, potentially, unless we need to wait for it to be inferred, right? And actually, right now, we removed the async from this. So, yeah, we just do it in these two steps, while previously it was happening in a single step. So this second step, when we do the assignment like this, we unify this variable and this. But over here, we already have done the type inference. So I know that the type of this is the thing which has the +1, which is int into int a function, right? So we do this already. Now, because I know the type of this, we can know the structure. So we do the value inference based on the type. Because the type is supposed to have a field +1, it means that this already is not completely uninferred. We know that there is a +1 field here, which is equal to underscore, right? What specific function is it equal to? We don't know, but we know that there is a field +1 in this. So yeah. Because of that, some actual unification might potentially happen. And it can fail. I'm assuming is what's happening here. So in our specific example, I say that my thing has the variant thing, right? So I say that let like option is none, right? Let's just do this. And then we see immediately that none is not equal to none, right? Even although it's supposed to work. So the problem is the variant types inside of here. What if I do const here? So this is, I guess it shouldn't matter, right? This is like option, I don't know, int32, for example. But I guess the type, it doesn't even matter here. Right? Yeah, we just say none is not equal to none. If I say like sum 1 to 3, it also, I guess, will not matter. It will say that sum is not sum, right? Yeah. Sum is not sum. So can I do this by having just a constant without it being, like, maybe it's not even about the module? Maybe if I just do this, then it also is not working already? Expected a generic over here. Where? What do you mean expected a generic? Option is not a generic? Oh, we say option T, right? That's correct. Yes, okay. Sum 1 to 3 is not equal to sum 1 to 3. Okay, this is a much simpler example. The modules are not the issues. Right? Sum 1 to 3 is not equal to sum 1 to 3 because we are uniting the things when compiling the const. All right. Actually, it's weird that I'm uniting like sum 1 to 3 and sum 1 to 3. Why does this even happen? Let's go look at the core syntax. Const let. So it's not about liquid cake AOC, right? It's variant constants are broken or something. So eval const. So I evaluated this constant to be equal to sum to 3, and then after that, let's see here. Like this is the unification actually, right? And then we say log const at this is unified with temp result. Right, because it's literally during this unification. Yes, it is. How about I also see that the temporary const at this temp result is equal to this. Let's print our temporary result. Like, what am I trying to unify here, actually? Yeah, so temp result is actually underscore, right? We don't know what it is. And I'm trying to unify the underscore with sum 1 to 3. And this is supposed to be done successfully. But it's not. Oh, let's take a look at the unification then. Or maybe like when I unify the variant, value variant, right? Oh wait, value variant, it literally always fails, lol. We have a to do here, okay. I guess I just need to do the to do. Alright, let's see. So we have a variant A and variant B. Unite value variant A, B, the variant. I want this to also be moved tuple A, tuple B, tuple unite value tuple AB. Just going to extract that into a function. Unite value tuple like that, and unite value variant. All right, so let's see. We have a value variant. Value variant has label, data, and type, right? So we must we must basically say that label span and value label span and value. Hello, Loki Abu. Oh, we have just label, data, and type. Label, data, and type. Okay. Label, data, and type. We return label, data, and type. Okay, so type is unused variable. Wait, OCaml allows me to have two function arguments having the same like variable names? Really? So like this name is just shadowing this value. Well, I mean, I imagine that I actually do this in my language too right now, but without a warning, of course. But I feel like this should kind of be an error, no? Like there are different kinds of shadowing. This one I don't think that I like. Label A. Data is data A, type is type A, and then label is label B, data is data B, type is type B. So when we unite, uniting the type is going to be unite type tuple type variant. Is it type variant data? No, it's type variant. Type A and type B. Data. So data is an optional place, right? So we should unite unite option, unite place, data A and data B. And label is unite label, label A and label B. Unite label is not done because I'm doing it differently in other places, right? Label equal. Do I not do label equal? Oh, we should do label unite actually. Which means that they are the same because I have united them. Okay. Interesting. So I actually do unite, right? Label unite. This thing just does not need a span anymore. Label unite is going to try to unite in different labels. Yeah, sure. So I think this should actually fix it. Okay, it did. So let's try the advent of code again. Liquid cake advent of code. It still works, right? Okay. Let's try the entire advent of code, but I mean, I only fixed thing. Okay, so I did not have a bug, I just had a to-do, basically. We have a lot of to-dos still. All over the place, right? If I try to look for to-dos, how many do I have? 95 to-dos in my code. Some of them are kind of okay, and some of them are just like bad error messages, and some of them are actual to-dos. Okay. Fixed inference for, I mean, not fixed, done inference for value variance. Okay, there was another thing that I was breaking. I remember when I was testing the advent of code, solving it with the JavaScript transpilation, then I actually had a bug. If we look at once again at this liquid cake solution, so this is like solving Sudoku-like puzzle, right? And over here, this is asserting that the answer is correct, right? So it automatically tests, because we know what the answer should be. It tests that the answer is correct when we are solving this, right? So if I try to run this right now, Advent of code. We are doing specifically the liquid cake here, part 2, right? Okay. If I do this, doing the JavaScript, right? This is okay. And then we do it on the actual input. So this is like the big Sudoku, not the small one, which is the example. Here's my answer, right? Here's my answer. But now, let's try not parsing this. So this is trying to parse a string into the answer in this case, I think is an int64 or an int32. I don't even know which one it is here. I guess I can enable the LSP for it. By doing this. So here is no, oh, it's projects, of course. Okay, there we go. So this is an int32. Okay, it doesn't matter, I guess. But the idea is that since this is an int32, if I try to not parse it, then this is just an int32 anyway, right? I should not need to parse my integers. I should just type them out as constants. So if I try to run this now, then it's going to say that expected 5173300, but got 517533251. So this constant got the last 3 digits replaced with zeros for some weird reason. If I do this as a number literal instead of parsing a string. That was fast. Well, I mean, this is JavaScript, right? If I try to run this through the interpreter, I think my interpreter, I fixed my interpreter speeds too. Let's see. But the interpreter is obviously much slower than my JavaScript. We will see, though, it to completion in not too long. Yeah, see, like, we are feeling the dots are the things that we need to fill in our Sudoku, basically. And once it's all done, at some point, that literally is not even that big, right? Yeah. I'm not sure what's happening here. We need to debug it. Number literals are broken in JavaScript. Right? So it works through the interpreter. A lot slower, but it works. But in the JavaScript, for some reason, it's not. So let's take a look at, once again, JavaScript. So this is my number. Let's take a look at the transpiled code. So transpiled code is over here, target compiled MJS. This is the code that this is the JavaScript that I'm running. Right? So let's see. I don't even have this constant in the thing. So I'm wondering... So, wait, hold on. How is this even being transpiled right now? I don't understand. Shouldn't there be a constant somewhere? Oh, or maybe I'm doing this in the... is target.js just doing it to a temporary file? Let's do output target compiled MJS to make sure. Like some of the constants are supposed to just be present in this code, right? So this is some constant string that, because I'm panicking with this string somewhere in option unwrap in standard library, right? So similar to that, my string there should be a constant. Hello, Deagle. A release. The release is supposedly this year, but I'm still waiting for my teammates to come and so that we work all together on the game again. It was supposed to be in January. Well, I guess January is not over yet, so maybe we will go back to Linksire soon. I can always just work on it alone, I guess, without my teammates, but, you know, it's just nicer when we all work on the game together. Right? Okay, let's take a look at the transpiler JavaScript. So we have a value int 32. Oh wait, hold on a second. Is it because of this? Because I do int 32 to float. Convert the given 32-bit integer to a floating point number. Is it because I'm storing in the JavaScript transpiler this thing as a is float in OCaml a 32-bit floating point number? It's not, right? Hold on. OCaml float. OCaml just has a single float, but I thought it was like 64 bits, so like literally the same as JavaScript is using for its internal representation, right? So it should all be correct. Maybe I'm not printing it properly. If I print a number, right string gx. Hello, Borchak. So first of all, why don't I even see this in my compiled code, which is very, very weird. Let's do some like very, very simple file, specifically something like this, you know, const x is equal to 1, 2, 3, just like this. Let's compile this code. Kast compile JavaScript. Examples test. Right, this is supposed to be a very small file now. So we have this temp, this value, which is 1, 2, 3, right? There we go. 1, 2, 3 is here. Okay. So I want to let's just copy this number and see what this is being transpiled into. Oh, there you go. Oh, wait, that makes sense. Okay. So this is that's why I could not find it, because it's being printed as a floating point number in this format. How do I make sure that I print it properly? Because, like, I'm pretty sure that the representation of my floating point is correct. It's just the printing that is done incorrectly, right? Very small line, 2.4 thousand. This is just me using the standard library. Like, it's because I have the prelude. It's because I have the prelude, so it is still transpiling the standard library. But I guess I could do the no std, right? And in this case it's just 400 lines, and this is just my runtime, which also I guess does not need to be included then in this case, because then we just do this. This is all that we have, like the 3 lines of code then. If I do it no std. But yeah, this is my constant. So I'm just printing it incorrectly. I'm looking for the printing. What am I supposed to do? Printing. Camel print. I'm not sure how do I get to this from the from the documentation. Got lost in the beauty of a camel website. Yeah. Hello, Pooh, daughter, coming. So I'm using the G. Convert a floating point argument to a decimal notation in style F or E. E, whichever is more compact. Moreover, any trailing zeros are removed from the fractional part, and the decimal point is removed. Like, I want the most precise representation of a floating point. Right? Or I just... the F is to decimal notation. It's almost decimal. Like, but isn't this also... Like, what is the precision of this thing? Is the question. I can also change my JavaScript AST, I guess, here. So I just literally say that JavaScript only has numbers, which are floats, right? But we can, when printing, print it as a normal integer. Is another thing. If I do F, though... If I do F, then it prints this. So this is the full number, but then there's a bunch of zeros in the end. And it's always like 6 things. But this is supposed to be integer, so I don't care about these things after the dot, is the idea, right? So I wanted to remove those. Any trailing zeros are removed from the fractional part of the result. And the decimal point is removed, right? So like this thing... Trailing zeros. It's only removed in the G, which is why I was using it, I guess. List lossy, 0b or 0x. X, convert an integer to an unsigned hexadecimal. Like... So, like, technically we are already, like, losing information because I'm storing... But I guess an int32 can be stored always as a floating point number, right? I don't know. Yeah, in a camel. It's an int64 for which I might lose information, which is for which reason I should use the big integers in JavaScript. But not for int32s, right? But it still is a floating point number, because that's what JavaScript is using. What's the best way to print float in a camel so that I don't lose precision and still use compact decimal representation if possible? Oh, there's also like percent 0.17g. What is so OCaml floats are the doubles. They have 53 bits of mantissa, 17 significant decimal digits. Prints just enough digits to round trip back to the exact same float. Okay. So yeah, it's by default it's losing the precision, right? The optional precision is a dot followed by an integer, indicating how many digits follow the decimal point over there. Or the maximum number of significant digits to appear for the F, G, and G. So what is the default precision? No one knows, right? So we need to figure it out. So G is still going to remove the trailing ones, but I'm going to give it a bunch of digits that it can print. Wait, can I just say, like, not even 17? Can I give it 100 there? You know? Can I do percent dot 20G? Like, giving it more is good, right? And then it just prints it as an integer automatically, even although this is a floating point number, right? If I had an actual floating point number, it would print it still, like, specifically as a floating point number, right? And that's all that I need to do, because 20 digits is enough for me, I guess. Okay, let's also make sure that the big integers are done properly. So this over here is an int32, and we want y, which is an int64. So what is an int64? Let's just eval here something like let mode x is 1. 18 digits, I think, is what we should be able to do, right? X times equal 10. So this is through the interpreter, and then through the JavaScript. Wait, it is still done properly. Because this is still represented properly in the int60, in the float 64, right? I need some number that is not precise there, right? Can I say x plus equal 10 and then x plus equal like I, and this is my I. Oh wait, this is now an integer though. I need to like convert. There's no way for me to convert the integers 32 into the int 64 still, which is weird. I should make the ranges polymorphic, I guess, too. Wait, do I not have the parse? Wait, why is parse not like in my prelude? Anyone knows? Okay, we convert to the thing like this. Okay, so this is my number, but this is probably not the correct number, because if I run this through the interpreter, then it's going to do this, right? Yeah, so we are losing precision here in the last 3 digits. Okay. So how do we do this? I want to int64 is not representable by JavaScript number. So we are going to use the big ints in JavaScript for this, right? So we have number, and then we will have the big int literal, right? Of so this will, so big integers in JavaScript, they are literally big integers. They don't have any precision limit, right? So we just give it a string, and that's all. And you just do like 1, 2, 3, B, right? No, it's not B. Hold on. JavaScript big int. It's N. N. If you divide this by 1, 2, 3, N. So this results always in the integer division, by the way. So we don't need to do the float round like we do for the normal integers. Is another thing. Hello, Nerdzel. Big int x. So I'm just going to write x directly as is, but I'm going to follow it with the n, I guess, right? Right. N. Transpiler. If I have a value in 64 now, we don't convert an int64 to float. Instead, we say that this is going to be stored as a big int. Big int int64 to string x instead. Okay, and then this number is exactly the same as this number, right? So this is actually calculated precisely now. Yeah, let's just make sure that the division is probably transpiled incorrectly for the int64s then. Y div 10 is y div 10. Right? So we just remove the last digit, kind of. Right, so now it says math floor, because that's what I'm transpiling my divisions into. But I guess div. Yeah, I also called it div temp because I want to replace with it with a different representation. Yeah, I literally say that if t is the floating point, then we just do the normal division. Otherwise, we do the floor for the integers, right? But if it is an int64, I guess, then we also just do this. But this should not be checked at runtime. We should just give it the something. But this is good enough for now. Okay. All right. So this is going to be discarded. Parse in prelude. Seems like the formatter did something new in the TypeScript code. Okay, sure. Fixed JavaScript integers. Okay. Still though, like one of the things that is not like working exactly in the native backend and in the JavaScript backend is when we do the overflow, right? So for example, if we do this, let's debug print x, right? X is 1, and for this in 0 to 64, x times equal 10, right? Like this. So since this is an int 32, it's going to overflow, resulting in 0 apparently in OCaml. Which makes sense, I guess. But then if we do this in the JavaScript, then we do this, right? But I think that is okay, because technically it's supposed to be undefined behavior, right? On overflow. For now, we embrace the undefined behavior here. And then later we can potentially add the checks. Like I was planning to. Undefined behavior. I'm actually wondering what's going to happen if you compile your OCaml to JavaScript. I'm imagining something similar is going to happen. Can I do a test? I think it's too much work to figure it out, though. Maybe. Dun, 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 dun. I need to do something like this. To do the JS of OCaml. In the OCaml playground. Right, can I just do print? Print int x, let x be int. There's no power, right? How do you do a power in OCaml? Is there no way? We need to write a loop like this. We just have the accumulator then. What do I do? 60? Like this? How do I make sure that it's been built? Example, no, maybe it's already been built. Default, OCaml playground. No. Figuring out how to do that. Name is OCaml playground. JS. Don't know how to build this. Can I just build everything? Maybe with June build. There we go. Oh, it's OCaml playground BCJS. That's what we're supposed to do. BCJS. So yeah, here's our JavaScript, and then we can just do like maybe node build default or camel playground bcjs, right? So it printed 1. Wait. Oh, to the power, yeah, 10 is the power, right? 10 to the power of 60 is what we do. It actually did 0. So OCaml is transpiling the integers into something else. Does it do the wrapping on the multiplication then? Can I see the code that is generated? Well, it looks like OCaml is also not being transpiled into something small. We have 45,000 lines of code for this. A little piece of code. Can I see the actual like source here? Pow. I would assume that some code like that should be in the end. Right? Is this the function d abc? Right? So if c is equal to 0, so c is the power. So if power is equal to 0, then we return 1. Otherwise, we return the function e. E is the multiplication. Okay, yeah. So we multiply a and b. A is the accumulator. B is my number, my x. And then we multiply this by the power of c minus 1. They do vertical bar 0. This turns it into an integer or something, I think, in the JavaScript. I'm not doing this myself, right? Because the vertical bar, this is the bit operation, which turns a floating point into an integer, I think, in JavaScript, maybe. But it's because camel mul, right, is the question. How is camel mul implemented? So just math I mul. Math I mul. Oh, the turns there is. Oh, wait, hold on. There is the 32-bit multiplication of two numbers. I can just use this then, right? This is in the JavaScript. We actually have that. Math object. Does this have any like overhead compared to like just the multiply operator? Returns the result of the 32-bit integer multiplication of the inputs. Widely available. I didn't know you can do this. All right. Well, I guess this is less undefined behavior and more defined, right? Or like, what is the behavior of this in the... this feature is useful for projects like Emscripten, which is like what I'm doing, right? Because IMAL is a static method, you always use it as math IMAL rather than a method on the math object you created. Method is not a constructor. If you use normal JavaScript floating point numbers in IMAL, you will experience it degrade in performance. This is because one costly conversion from a floating point to an integer for multiplication, and then converting the multiplied integers back into the floating point. However, with Asm.js, which allows JIT optimizer to more constantly use integers in JavaScript, multiply into numbers stored internally as integers, which is only possible with ASM.js, with IML, could be potentially more performant. So, hold on. Should I actually use this or not? Because I'm not generating like ASM.js. I'm generating like regular JS, I think. I can test the performance actually easily though. we do the multiplication. Maybe like cast run. I think day 10 of the advent of Go. This is where we do Gaussian elimination. Right? And then there is also combinations. Actually, this is still very slow for me right now. Maybe it's actually better in the liquid cakes thing. With the Sudoku still. This also times the transpilation time, but maybe this... Maybe we'll do something like this. Cast compile target JS liquid cake main JavaScript and hyperfine node target compiled MJS, right? So that we actually test this separately, right? So it takes 74. Oh, but this is on the input, right? We need to do part 2 input txt here, right? And then it takes, yeah, so it takes like 1.2 seconds right now to perform this. Okay. And then in the runtime, I can try to change the multiplication. So I just use the multiple lie operator here, right? Should it depend on the... I mean, if in this example I only use the int32s, then maybe we can just do math imal. Can I say just 0 left-hand side, 1 right-hand side here too, by the way. Left-hand side times right-hand side. Plus minus. Future programming languages would have a vibe operator. Okay, 1.250. So if I do, let's just replace one of these, right? A math dot imal left hand side, right hand side. Since I'm pretty sure that I'm not using the floating points or int64s even. So this actually did like increase the performance. Increase the time, right? So it hurts the performance. 250 more milliseconds. If I do over here too, math wait, math I sub is not there. Why is it specifically the multiplication is the only thing? It's only the multiplication that needs to have special treatment. And the other things, you just use the normal operators. I see. Okay, we're just going to ignore this. We go and say that it's undefined behavior. It's fine. Don't overflow your numbers. For now, it's okay. All right, what next? What should I work next on? I wanted to do like some sort of the derived macros. Derived macros are really useful. Vibe time evaluation, vibe function that takes folds left. Yeah, no. Don't think I want that. I wanted to look into the how would we do the derived macro, right? Or maybe like before that though, we need to like improve the macros in general. Specifically, there is no hygiene of the macros right now. So let's go to a test and let's have a macro. So macro is just a function that returns AST, right? So we have a macro, which is a function that takes AST and returns another AST, right? Let's say like AST plus AST, right? So if I say dbg print macro 2, this is going to result in 2 plus 2, right? So 4. The issue though is if I say let x be AST and then I return x plus x, or I mean, let's just say that let x be 1 to 3, right? And then I return AST plus AST. So I still use the original AST here, right? It seems like my Kast is having an infinite loop right now, my LSP. Yeah, something was weird there. Okay, so this still... Wait, hold on, this still says 4. Oh, because this is 2, right? But let's say that over here, I say that I do x, right? Because this is supposed to, like, say x plus x, and x should be taken from my original scope here. X is 2, right? So this should actually print 4, but it prints 2, 4, 6. Because my macros are not hygienic. Let's call it twice. Oh, let's call it double. So this should return let x be 1 to 3. AST plus AST. So this prints 4, as it should in Rust, for example. But it's not doing this for me. Macro hygiene. Let's do this. It's not that difficult, is it? Okay. Okay, so the idea is that this x is different from this x. Even though they look the same, they are not the same. So we should look... Hello, Raymarch. Hi. How are you doing? So the idea is that this x, because this x was constructed here, it should be looking in this scope, but this x is constructed over here, so it only exists in this scope. Even though I'm replacing AST with x, it is still should look the x in this scope and not in this scope, which is generated. Remember you tried and gave up in both previous rewrites? I think I had the micro hygiene before, no, in my Rust version. I'm pretty sure it was working. So the idea is that my AST values, right? My AST values are going to have extra data associated with them, which is the scope in which the in which we should be looking things up. I can actually just look at my old implementation. I think maybe this is easier. Let's open it here. Just do the cargo check so that we have the Rust analyzer working here. Even check-in takes 1 minute to finish. I think I want to value. So these are all the values that we had in my Rust rewrite. We have the AST. Let's wait for the Rust analyzer, right? So yeah, AST is AST data. So AST data has this information. So right now I'm storing for my ASTs only the spans where they were constructed, my ASTs, right? But we should also say the definition site, which is the compiler scope, which is the scope in which we should look for the variables, right? And the hygiene is the enum, which is just the def site, right? Like there is some value in having non-hygienic macros, but most of the time we want the hygienic. So when we look up the symbols, we should look at the definition site. So we store both the definition site here and whether we want to use it, I guess, right? Or maybe we could store the def site in this enum. I guess it doesn't really matter. Yeah, we can just do the same thing here. But here's the thing, right? So the parser should not know about this. The parser should not know about this. So because of that, in my Rust rewrite, we had the AST, which is a generic thing. So this is a generic thing of what is the data that we associate with every AST node, and by default we were associating just a span. But once we are in the interpreter, we want to also store the other information. My Kast AST right now is just this thing, which is just having this span field, right? But we want other data. Do I also make this polymorphic then? Generic? Just like before. So we have like, you know, data t. You know, data is our generic argument. And we have, instead of span, we actually just have the data, which is of type data. So when I print, in order to print the AST, we need to also supply the way we print data. I don't want to do that like that, though. It's because ASTs can contain other ASTs inside of them, right? Yeah, so my children is just this, and this should be different. So everything is now going to be generic. I have to change this, right? It's either I change it here or I create a new AST struct in the other place. I can also make this to be a functor instead of being polymorphic, right? Yeah. I actually, yes, I can. I actually can do this. Maybe that's what I should do. So we say like module make. So the data is what we associate with every AST node. And then we have module type data s. So what we want for the data is to, like, data should always contain the span. So we have like span is t into span, right? And maybe this is enough. So instead of saying ASTT here, right? So this is the parser. Or maybe like I should have, you know, module, it's like by like the default AST, which just has the span, which I use. We can just say that this is make, this using the span. So span is just t is span, and span span is span, right? So we say not ASTTT, we say ASTTT, right? In the parser. Or I can say that I can say that module AST is cast ASTT then. It's like, so the parser only cares about the spans. That makes sense. But then we will use a different module in other places. So over here, right? So here's my value AST, and my value AST should not be the original AST. Or we should rather say that module AST is something else. But module AST should contain the compiler scope inside. And so this is going to be part of this recursive group too. Oh my god. Oh my... my. And we go back to the OCaml and the recursive functors. And I'm going to hate my life again, right? Alright. You need to say something like, and AST is cast AST make using the AST data, and AST data is struct. So the AST data should have cast AST data signature. So we will have span, and we will have the and now I need to give it the type. So the type then should be cast ast.s, which means that cast ast make should return s, and we'll have module type s. But now I need to duplicate this thing there, right? Maybe. Can I just have type T? Can I have a val print formatter T unit? Can I have type part? Can I have type child? Constructor comment. I guess I cannot really, right? We need to have I actually need to have this. All of the types here. And complex and group and shape and T and AST. I should copy paste this in my signature. And the single too. The simple. Signature mismatch. Type syntax is not included in syntax. Fields don't match. Mode A is not mod syntax mode T is not equal to mode A. Oh, because syntax mode is not even defined here. So I need to have the syntax mode. We just have the signature here, I guess. Type T is this. And then we have a val print formatter T unit. Okay. Unbound value AST shape. Dun, 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 dun. Wait, why do I even need the AST shape? In file none also is a beautiful OCaml error. Like what file? Like what are you even trying to compile here? At least can you give me the module? No, you cannot. No, you cannot, because you are OCaml. Okay. Is there a way... Can OCaml give better error message? I don't have file none. Because it's generated code, which makes sense. But what was the code generated from? Compile real files. It's because I use ppx, I assume. But can I have better error message without getting rid of ppx? Force Dune to show ppx output. Just do the verbose and that's it. Oh, we also do profile dev. Whatever that means. Maybe. Dune build. Profile dev. Does that actually... No, this does not change anything, right? Verbose. So does this mean that it's trying to do the parser? Right? Kast parser is the thing that I'm trying to compile. Okay. Yes, because the parser does need the shape, indeed. Okay, and now I have the cast types. Flatten children, it also needs to be exposed. Child tuple into AST tuple. Unbound time constructor ASTT. In the interpreter core now. Okay, yeah, so the interpreter core should now say that AST from this, right, it should not be cast AST, it should actually just be, well, I mean, it should be just in the cast types, I guess, right? So just say module AST is AST, which is this thing. Compiler. Just remove this. The field access parsed AST has typecast AST TT, but an expression was of type ISTT. That's right. Okay. So when I am compiling, so the parser is giving me the AST, which does not contain the like original value, like this extra information, but we need to convert it into the thing that has the extra information, right? So I need to convert my AST and convert the data. And I am not sure. Well, I mean, I guess. So parse the ST. Parse the ST. AST. I need to map. Well, if I map, it's no. I need to have some sort of a function, right, which converts the AST like into that stuff. You know, maybe I should call it init AST. This is in the compiler. Let's just have this function here for now. You know, let's say that we have a rec init AST. So this should have cast AST TT, and this should return AST T, right? There you go. So it's a function AST. So we should return shape is going to be match AST shape. No. No. Yes. And data is going to be the data. Oh wait, and ASTT still has the span. It should not be the span though, right? I'm now making it using the data as. Oh yes, so this should have instead data, which is data. And yeah, and I guess we have the type data equal to data t. So we have type data in the signature here, and AST t should have data, right? Unbound value equal data. Yeah, so we need to be able to have the equality in this. Equal data tt boolean. Compare data. I mean equal and compare. tt and deriving accord. Equal data is data equal compare data. Let's just say module data is data, and I say data t, and over here we instead say that module data is data s. Right, so when I print, we have the data. So then I say that span is data span of data, basically, and that's all that I need to do. Equal is span equal, and compare is span compare. Now in the parser, we don't have this thing because we need to merge span, because the data is basically span now. But data has type AST data t, which is not exactly that. Okay. I should say that t is make. So this should be s. But it should not be s. It should be s with module data is data. Is that the correct thing? So in the parser rule, data is span. So just span was renamed into data basically everywhere. In this case. Types don't match. Oh, I need the equal now for my AST data here, right? So let equal. I mean, I just derive this thing though, right? Deriving accord span t. Okay. So the interpreter. Yeah, so in the interpreter, when we quote the AST, we say unbound module AST. That's not really true. We should say that data is span. unbound record field span. Data is AST data T. Data is span. No, I'm pretty sure data is this span because AST is this, but it should be cast ASTS with module AST data is AST data, so that I can actually see this thing over here. But I cannot do this. Wait, hold on. Is this even possible to have these types in a camel? I cannot get rid of this and make this not part of the recursive module group, because this will have the compiler scope inside too. But this is not just case ASTS, right? It's cast ASTS with module data equal to AST data. But this is not possible because this makes the module type recursive, and that's what OCaml doesn't support. We are back to the issues of OCaml. But I can say with type data, I can say though that type data T is equal to AST data T, right? I can do that. But the AST data T is too abstract because I only give it this thing. So I say that with type T is equal to span is span T. I need to like duplicate this thing here, right? I can make this in part of my types though, right? Types impl. I can make this part of my recursive group, right? Types impl AST data. Yeah. And we just say that this is equal to the AST data. And this is also data T is types impl AST data, which is supposed to be the same thing. And so types impl is going to be this recursive bunch of types. Where we have AST data is this. This should be part of this group, for which we are deriving this stuff. Here and in the signature. So I need to copy paste my stuff 1 billion times like always, but it's okay. So now this knows about this, right? Okay. I like how this error is not red, even although the warnings were colored. Yeah, maybe I should look into self-hosting, because OCaml is just pain when we need to do this. Empty. Yeah, so init AST is converting the AST into the AST which has the extra data, right? So, yeah. So this shape is going to be AST shape, which is similar to this shape, but it's different, you know? Simple. Empty, empty. Simple, simple. Complex. Complex. Syntax. Syntax. Error. Error. Wait, why is the error having some... Oh, it has the parts still, I see. Yeah. Error. Parts. Error. Part is init ast part. Parts list map. Init ast part. Init ast part is cast ast t part into ast part. Function. Init ast group. Cast ast t group into ast group. We just need to map the parts. Children. So this should be child. So if it's AST, then it's AST. And if it's group, then it's AS, and then it's group, init group, G. Okay. Simple has the simple. Simple is just this thing, which is just the tokens. Okay. Syntax. Comments before, mode, tokens, value after. Mode. Actually, syntax mode can be defined on the outside here. Same goes about the simple. Because this is not dependent on the data, right? At least for now. At least for now, we can remove this. And we can move this to the common stuff on the outside. But now we don't have AST syntax mode. Okay, fine. We can just say that type simple is simple. This is not working. Type. We can say module. Syntax mode is syntax mode though. Okay, back to the compiler. Okay. So simple, simple should work properly, right? Now we just have the value after, which is AST option. So this is going to be a value after option map init AST. Okay, and then we just have this complex node, rule and root. Rule and root is init AST group root. Okay, and this should work. And then data. So now the data, right? We have the initial AST data, which just contains the span, but I need to give it something else, right? So this should be AST data, right? So this should contain the span, which is AST data. Right, and then if I add more data here, I will just need to add stuff in this place. Okay, nice. So AST span is now AST data span. Also, ASTT, we don't do this anymore. AST span should be AST data span. And it is like that in a lot of places, right? Yeah. Let's just say all AST spans. All AST spans should be AST data spans. Okay, AST collect list is not exposed. Right, collect list. Needs to be a part of the signature. Over here. Data span. Data span. Data span. Data span. Can I see anything? Like, can I do a find and replace? You know, where we say like dot span. Can this search be done with a regex? Regex. But I want something that's like, you know, dot span. Dot span. I want to find the dot span, which is not prefixed with data dot, right? How do you do this in regex? How do you do a not in a regex? How to write regex which matches dot span unless there is data before, so it shouldn't match data span. Question mark less not data. Okay, let's just do this. Is this going to work? Okay, I think this actually is working. So then we replace this with data span, with dot data span, right? in all of the places. Okay, this actually works. I think there is still a couple places where they didn't work. All right, because parsed AST in this case is the parsed AST, which is the original AST, but I need to have parsed AST compiler init AST, I guess. And same goes somewhere here. Wait, what is this group data span? Oh, because groups, they don't have the data associated with them, actually. Okay. Does this work? Kast compiler. Okay, now this over here, AST, is not Kast AST. And this span is not this span. This is like data, which has the span, I guess. And AST span is just span. This is just span. Span, span. Span, span. Span, 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 span. AST span is just span. Span, 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 span. And what is this now? So we compile AST, some AST data span URI. This is the currently compiled file. Okay. Okay. Include Kast types. Multiple definitions of module AST. This AST is Kast AST. Remove it. Parsed AST here. So parsed AST, this Kast compiler CLI, because we need to compile. Compiler init AST. Right? So which means that this should also be exported. Init AST is compiler init AST. Sure. Kast compiler CLI parsed AST span. Can I just say that this is my AST? And this should be just AST data span. LSP processing. AST. AST is Kast AST TT. So we compile this. I will just say that AST is compiler init AST AST. Semantic tokens. AST is not Kast AST. Wait, or is it? Hold on, semantic tokens. AST is Kast AST T, I guess, here. Collect data. Unbound. No, this is working. Okay. Compile parsed AST. AST. AST is parsed AST compiler init AST. Find spans Kast AST T. Data. Span is AST data. interpreter CLI. Kast.js. Okay, success. Okay, so everything should still work like before. I just it doesn't. I just added a field. Like I mean, I just have like the thing. All right, cast parse examples TS test. So it was parsed successfully. Compile. And compile doesn't work. I'm assuming that this is the init AST because that's the only thing that is potentially broken. The ASTs are never recursive though, so right. So like, why would this be broken? Oh, I know why though. I know actually why. It's just very slow. Because once again, because we have children and we have parts in the group, right? This over here. So because I actually store the same value in multiple places. So this is exploding because it only, yeah, needs to do everything once. Is the child and is the part, right? So this AST and this group are both done twice. Where did I have the same issue before? In the rewriter, right? So in the for FMT CLI, I guess over here. I did a hash map before, but then I redid that because I just map the children and then I do this. Yeah. Okay. I understand. So I need to like do the children first. Children is children mapped. But then when I construct the parts, I need to construct the parts given the children. Right? So when I have the ASD or a group, I need to get it from the child. From the corresponding child. And not map it again. Because it is already mapped. I need AST part. And AST part is also done here. In the case of the error, I don't need to do that. But I need to do it over there. Bum, 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 bum. I need to have the unnamed child index. Also, in this case. Another option is to change the way I'm storing my ASTs. Maybe. Would that be too much work? Because AST child should be this, but AST or a group like this should just... so a child could just be an index into the parts, potentially. And then I don't store the same value twice. But do I want to do that? Because that will require even more changes, probably. Everywhere. Or I could have the part, and a part is like a child. Yeah, maybe my parts could have... or could reference into the children instead of children referencing the parts. Or I just do the hash map to see if I have seen the thing before. But then this needs to be done within within a context. Let's do it the same way as I was doing before. So we just go on over the parts. Let's just do this. Init AST parts. Parts, right? And init AST parts is going to be part list into AST part list after all, right? So we're going to say function parts match parts. If it's empty, then return empty, and if it is part followed by the rest, then we say that part is this, and then we say part followed by AST parts rest, kind of, right? So part is AST part. But which is this is basically same as a map inlined. But I want to give it the children, right? So it's going to be Kast AST child tuple. So this is going to be children parts, and this I will give it the same children. ST child. So I give it the children here, so that we can reuse it instead of initializing this recursively. Well, I mean, don't I just say here still list map parts? can still do it with a map. That we're going to have the unnamed index. Dun, 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 dun. And then get member, string option, unnamed child index. It's going to be a reference like this. So over here we have a value. So we're going to say children, tuple get member. Wait, how do I know if this is named or not? Because I now need to know the parts. If they are named or not. Oh my god. I could store the information here though. Wait, I think this is a good idea. When I have the part, I can do like the tuple member here actually. From the original, like I mean, yeah. Which means that I actually store it differently. So group and value should be the members of the children. In case we have parsed successfully. In case we are not, then no. Annoying. So in AST, I store the child nodes in two ways. One of them is basically a map from the child name to the actual child, and one of them is just them in order as they appear in the source code. So that we can reconstruct the source. Like I need to actually have the rule parts here. So we need to AST parts should also have the rule parts. Right? Init AST parts. But in case of an error, I don't have it, by the way. So in case of an error, I only store the one part because we have not parsed it into a structure, so I don't know the thing. I just know the parts. Maybe it is easier if I just do the just the memoization basically. So over here, have I done this before? All right. Let's store this inside of a module init AST. And then we'll say that init AST is init AST, but we're going to like wrap it into the function which introduces the cache, so that we like do the thing. Recurse cache. Init AST. Fine, let's do this over here. Module recurse cache is recurse cache make ID. It's just a hash type, right? I can just make it an int, I guess. Right? Recurse cache with cache and AST recurse cache create function init AST okay, like this, or init AST. That's what we do, but we make this thing over here. Let init AST is this. We do it with cache, recurse cache, and then over here we see if this was done already before, right? So we're going to match recurse cache is visited ID. Not even the recurse cache, and have an actual map. And have an actual map. Fine. We just have type context, and we have a type effect t plus equal get context effect. I just say hash table int into AST sure so this is going to be not with AST, we're just going to try init AST with effect get context effect continue context, and we initialize the context here. Okay. So now we say what? We say match hash table find opt in the context. I'm trying to find the ID, and if it is some result, then we just return the result. And if it's none, then we need to calculate the result. Hello? The formatter of a camel is like taking 1 hour. Right, so we say that result AST is this. We return the result, but we say hash table add ID result. Context ID result. So what's the ID is the only question, right? So we need to convert the AST into the int. Just do object magic. AST, I think. And then this should work. Maybe. Okay, yeah, seems like it did work. It's a little cursed, but you know, using the magics. All right, but so now this works, right? I just added the extra, like I added the possibility to add extra data to the ASTs once we are parsed the parser and we are and we have processed the ASTs through the compiler and stuff, right? I can add extra data there now, right? Okay, AST different ASTs for parser and compiler. Something. Okay, and now what is the actual data that I have, right? So AST data, this thing. I should have the span. I should also have the hygiene, right? Which is AST hygiene. And I should have the definition site, which is compiler scope option. Right? And IST hygiene. So we are just going to have the definition site for now, just like before. But maybe at some point we will add the non-hygienic macros back. All right. So now when I quote AST, right? This is my interpreter core. So in the interpreter, quoting the AST is constructing the AST. This is where our macros are actually working, right? So the span of the thing the span. So this is the span where the quote was created. Right? So this is going to be my definition site then. Right? So yeah, when we create a macro like this over here, this is the quote. So we are creating the new AST. So the definition site of this AST is whatever was my compiler scope over here, right? Wait, but do I even have the compiler scope here? This is the interpreter. Interpreter does interpreter contain the compiler scope inside? Not really, right? But I do have the expression, quote AST expression, which should be able to know the compiler scope. Yeah. And hygiene. All right, so let's see. Hygiene is definition site. And definition site itself is so this should be also stored in my in my compiled expressions then. Right? It's when I'm compiling that I'm recording the compiler scope. Quote AST, or at least like in the quote AST itself. Expression. Right? This thing can have the compiler scope, which is compiler scope. So definition side is expression, compiler scope, sum. Why is this optional? I don't know. Maybe this should... it's okay. So when I quote AST, this is completion. Compiler scope is irrelevant to the completion. Okay, so when I'm constructing, so init AST here, right? Hygiene is definition side. Definition side is none. So initialization AST, this is where when we start compiling. So the compiler, we don't even know about it yet, I guess. Construct group. So yeah, when I do the quote AST, right, this is what I'm compiling. Now this is where I know the compiler scope. So compiler scope is going to be C state scope. Whenever I'm compiling this data, I care about the span, but I don't care about the other things, I guess. Okay, so this is still working, but now the idea now is that this over here, right? I'm compiling a simple token, and we know that this is the identifier. So this is it. In which scope should I be trying to find the thing, right? Find binding. So right now I'm trying to find the binding in the scope where the AST is being expanded, but I should try to find it in the original scope. In the original scope. And I guess this should also depend on the hygiene, actually, right? This should actually depend on the hygiene here. So here is my AST, and this has hygiene and definition site, right? And it should affect me handling the identifiers. Identifiers are just place expressions. That's the only thing that I should be worrying about, only this thing. Only this thing specifically. So it just depends on the scope, right? The scope depends on my on the hygiene here. So let's say scope, and then I say that your macros are checking for name collisions. That is what the hygiene means, right? Yeah, it depends how do we do the symbol lookup when expanding the macros. Here's example in Rust, right? So your macro has as its argument this name x, right? But inside of a macro, I am expanding the macro and I'm introducing a new variable named x, right? But this should resolve based on to like the original x here, so that your macros are predictable. That's why the hygiene is important, right? And it should not refer to this x that I defined here. The other solution is basically over here when you are creating your AST to create a new symbol, which is not X, but something else, basically, right? So in Lisp, you would generate the symbol for every like new variable that you construct in your generated AST. But we want this to be done automatically. Right? It's not exactly like, well, I mean, it is solving the name collision problem, right? But right now it's not even an error. It is just like yeah, it's just like looking the things up incorrectly. And another thing is a different way, by the way. So let's say that I have a macro and I want to refer to the symbol which was available to me at the macro definition, right? Yeah, they just have the function called gensim in Lisp gensim. But also, like, even the Lisps are there are Lisps with macros hygiene, Lisp macro hygiene, maybe like in the maybe in Clojure or something. I don't know. I don't really like use the I didn't really use any of the Lisps, but I'm pretty sure there are with hygienic. Yeah, this scheme is still a Lisp, right? But this one has the macro hygiene. But in a regular Lisp, I guess by default you will have the problem of the with the name collisions whenever you are generating code with macros. Yeah, and like I was saying, you can have a thing. So like in Rust, it's actually a little bit annoying, right? So in Rust, your declarative macros, for example, they have a dedicated thing which is called crate, because if you want to refer to the symbol which is defined locally at your macro definition, then you cannot do this unless you use the special thing called crate, which is also completely impossible to do if you are doing a procedural macro in Rust, because there is no alternative for that in the procedural macros, right? But basically, if I don't say, like, let's just say let x be equal to y, right? What does this y refer to? You ran into this so bad, right? So like, let's say that this y is like, this is inside of a module, right? Module foo. So inside of the module foo, I can generate a, like, say a constant y, i32 is equal to 1 to 3, right? So this is what I want, right? But if I try to actually expand this macro, this also, by the way, doesn't work right now because macros live in their own, like, namespaces. So this is not namespace into the module technically right now, right? Which is also supposed to be fixed with macros 2.0 or whatever. So right now this is still going to be double, right? So this is going to say unused macro definition double. No, I need to wait, hold on. I need to do like macro export here. Is this not possible at all right now? It cannot find it. Well, yeah, right now all your macros must live in the crate root, I think, also, which is really annoying. So I cannot even like show the problem here unless I create it with a different crate. But imagine that this is a different crate, right? Then you would be able to do foo double, right? But because this is going to expand to let x equal to y, y is not going to be found in this scope, because in this scope y doesn't exist, right? It only exists in the original scope. So you solve this by using crate colon here, right? But I want to do it so that it's just done automatically. We are going to capture this thing from the original scope where the macro is defined, and it's going to work with, because my macros are all just procedural macros technically, right? So we're just going to capture whatever is available in the current scope automatically. And in the end, I learned that people basically do doc hidden mod private, and that doc hidden and semver private. Yeah, but you cannot do this in the, well, I mean, when you are having a proc macro, there is no reliable way of resolving the symbol correctly, right? So whenever I was writing my proc macros, I just assume always that there is a specific symbol in the target scope, which resolve to my target crate, which I like want to actually refer to. Right, like when you derive 30 serialize, it assumes that 30 is present in the current scope in the form of like external crate. It's like too special. I don't know. Rust is just doing macros wrong, I think. So yeah. Also, it's annoying how hard is it to find the definitive guide on how my crate should behave there. I had to piece it together by reading this error and whatnot. Find the definitive guide of how my crate should behave there. Which crate? The crate that implements the derived macros, or something? There is also like also if you look at something like Bevy source code, right? Because Bevy is a project which consists of a bunch of different crates. So your derived macros are declared in certain crates. So like, you know, your derived macro is basically actually going to read your cargo toml to figure out what your crate depends on. And if you depend on the crate with the like which is supposed to be like the thing that the derived macro is supposed to generate to directly, then you are going to use that. But if you depend on the Bevy itself, which just re-exports the child crates, then like it just generates the code differently. It tries to do some smart thing to find the crate properly. I think I did this myself also. Maybe, I'm not sure. Maybe you should do something similar. I don't know how many crates you have in your shame. Like, we have the gang derive here, or whatever, right? Or ugly derive, for example. Right? So what am I export? What am I having here? Oh, I just see. Yeah, I just do ugly. Yeah, okay. I'm just assuming that this exists in the current scope, which can only be done if I import the prelude, actually. So I'm assuming that the users are going to do something specific. I think it's not everywhere. Maybe like in this set of crates. Where would I derive something here? Diff, maybe? Derive. This needs to be solved on the lang level. Yeah, that's what I'm saying. That is what I'm saying. No, I don't do anything special. Yeah, maybe... I remember that I was doing something special, though, in some place. Maybe for my assets? Because I derive the assets? How does this work? No, this just does that. Maybe I tried it at some point, but then I did not do it. Wait, I can show you the thing in the Bevy. I'm not sure if I can find it quickly, though. Like, let's say that you have derivers in your crate, right? What crate does the derive? Like Bevy ECS, I guess, right? Is the important one. Bevy ECS. Macros. So this is the thing with the derived macros, right? So let's say that you are trying to derive the world query. So what are you implementing this here? right? There you go, path, right? Path. So what is this path? This is the path to the crate which contains this trait, right? Path, scene path, world query impl. And then there's like a special crate somewhere which finds the path to the crate. If I can find it. I probably can find it. Bevy macro utils, probably this one. Hold on. Wait, where's the Bevy macro utils coming from? Bevy macro utils. Crates. Bevy macro utils. Why don't I see it here? Am I blind? No, it's here. Dun, 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 dun. Bevy manifest. Oh, there you go. I think this... There we go. Attempt to retrieve the path of a particular package in the Bevy manifest. So it's basically parsing your cargo TOML. It tries to find the Bevy. And so like, because the name that we're looking for here is the name of the crate in the Bevy like set of crates, right? So it is either available under the name like Bevy like ECS, for example, if we talk about the ECS, or if you derive, or if you depend on the Bevy ECS directly, then you have in your dependencies Bevy ECS, basically. Something like this is what this code is about, I'm pretty sure. Right? Yeah, there it goes. You have Bevy underscore, that's your thing. Yeah. In dependencies, if dev dependencies... Alright, anyway. I assume they handle the cargo renaming syntax correctly. I don't know, you probably... I don't know if they, like... Because there is the, like, cargo metadata crate, I'm not sure if they depend on that. Or if they parse it, like, they should not parse it themselves. But they don't actually depend on it, which is weird. Because there is a specific package which helps you to like parse the cargo metadata and figure out your dependencies properly, right? Unless they have their own implementation here, like Bevy manifest. Cargo manifest dir, cargo TOML, right? I guess they have their own implementation of it, which might not be like synchronized with the Rust, actually, potentially then. Well, I mean, and cargo metadata is a separate crate, which also is not necessarily synchronized. So yeah. Alright, whatever, let's go back to implementing the thing that I was going to do. Which is this over here, right? So the macro hygiene. If I have the hygiene here, we are going to say that what the scope is. So the scope is either the state scope. That's what it is right now. But we're going to match the hygiene here. And so the non-hygienic macro would just get from the current scope, which is my current behavior. But if we want to find the definition site, what Windows Manager I'm using? Hyperland. Hi. So the definition site, then I'm going to match definition site. If it's none, then there is no other way than doing this. But if it is some scope, then it is scope. That's what I want. That's what I want. But I guess the definition side needs to be handled appropriately, because this is still not going to work, I'm pretty sure. It's still 246, because I'm not assigning the definition side to all of the ASTs, but only to the top level AST when I'm constructing this macro, right? Yeah, so this is in the interpreter. When I'm quoting the AST, I say that the definition side of the AST which we get in the result is the compiler scope, but I don't do this here. So I guess the quote AST child is another thing that should have, right? Children group, children map, AST child. This has the AST. So if this child is an expression, quote AST child. Quote AST child is either AST or a group. AST is just another expression. Oh, wait, hold on. But another expression is what? Wait, maybe this should be correct. Oh, wait. Hold on a second. Hold on a second. Hold on a second. Test. Can I say over here plus X? Or hold on. Let Y be equal to this plus X. So this is X because it was constructed here, but this X is constructed here. This X should not should be not found, but it is found. Quote XT is an expression which always constructs the thing. Yeah. Hold on a second. Maybe it's when I'm compiling the AST core syntax. Quote, right? This quote. This quote says, no, it says that compiler scope is the scope. For sure. Unless it's the AST, which is the original AST. Oh, okay, hold on. I'm quoting the ASTT. Wait, should... hold on. The compiler should take as its input the AST, which is not this one, actually, but a different one. But just the parsed thing. Right? Yeah. Module AST is Kast AST. Or should it not? Wait. Should it not? No, it should not. Because I'm potentially compiling the generated code. Yeah. Wait, hold on. So the thing is also, if we talk about the macros, right? That over here inside of this macro, I can have another AST, right? So in this case, we're putting the AST, which is the input to my macro, but I can give it also the AST, like, you know, X, where X is just another AST constructed here, you know? Something like this. X, where X is 3, right? So in this case, this X should be 3. So this X which is this AST, refers to this symbol, right? Value shape X, inference error. X is not equal to X. Wait, what? When I'm compiling this? Excuse me? This X is not equal to this X. Oh, wait. Value shape. This is a quoted AST, right? I don't have AST in my standard library. I should have, though. stdlib. I should have the types. AST type. Here's the AST. Could not find the AST scope. Wait, why not? Oh, because it's not part of the it's not part of the prelude. I can do std though. This over here is weird. What's the issue? Oh, wait, value shape X is not equal, right? X, this is the AST. Okay, AST is not equal to another AST, which is itself. Okay, I actually understand. It's the same issue as I had before with the variant constants are broken. So this is in the inference. If I have value AST, then it's not like... then it's always failing. But I should say like VASTA and VAST... B, at least when they are physically equal, then we should just do this, right? And this should work because they are supposed to be physically equal, right? Yeah, there we go. So we have now 4, right? So yes, but this X is supposed to be this X, which is referring to this symbol 3, right? Yeah. So why is that? It's because when I have Kast, no, if I have the core syntax, quote AST. So like, so this AST is constructed without a quote originally, right? And when I do the quote like this, so this AST is a single token, which is the identifier X, right? And I just initialized this AST, so the definition site is none there, right? And then when I pass this to the quote, I just return the AST as is, right? So we return when we are quoting the AST, if it is as simple, so we have a const shape. There we go. We have a constant AST. But I should replace the definition site with the actual current definition site. If it is not the AST, which was constructed through a macro before. Right? So I need to have the I need to have like something very similar to my init AST, but I need to like populate it with the definition site this time. So I need to have this AST, let's say compiler, initialize AST definition site to be state compile scope. Right? Okay. So I have something very similar to this init AST, but we don't convert from the original AST, which does not know anything about the definition sites, but we convert AST back into the same AST. Let's just copy paste this for now. Maybe I can do it without duplication. I probably can. Init AST definition site. Init AST definition site. It is very similar, but it should take not this. It should just take AST and get me the AST back. So this should have the so this should have AST and it should have the scope as my argument, right? So my context here is also going to contain the scope. So this is already initted, I guess, and we have the scope, which is compiler scope. All right, so in this case, the definition site is not none, but definition site is either the original AST definition site, or and like the hygiene, I guess. Hygiene also is equal to the original AST hygiene. But the definition site is either this or the current scope. So we say option or some context scope. Right? So it's either the original definition site in case I constructed this AST through the existing macro, or the current scope. So it's always going to be some here. Okay. Field C state scope has type compiler scope, but an expression as type ASTT. Oh, this is NNST def site. NNST. Okay, is this going to work now? First try. It's just not working. Because it could not find ref in scope over here. Oh, wait, this kind of makes sense. Maybe? Wait a second, hold on a second. This is a little bit weird. So this is a macro, minus equal, right? We are rewriting this into that. So now that the macro is hygienic, this ref is trying to be found in this scope, because that's what we did. But we have actually generated the symbol inside of this AST, and so the scope in which this should be found is the is something else. Oh, wait a second. I think I know. No, it's not like this. I should not initialize the definition site. No. So this AST is having the, like, is recording its definition site when I was constructing it, that it was constructed over here. So everything that is available in the scope of the definition should be available to it inside, right? But when I'm compiling the thing, the AST, I should switch my scope of the compiler to this scope. Right? And then over here, this one is the AST that was constructed in the other place. So we're going to switch back to the original scope. Is the idea. Yeah, maybe I don't need this that I did right now. I need dev site. Delete. Let's get rid of this. Hold on. Yeah, but when I construct the quote AST, I should definitely remember my current compiler scope. And not only if it was complex. If this AST is a simple one. No, this is fine. Yeah, if it's the simple. Hold on. I just need to replace its thing, right? So let AST be AST with definition site being AST definition ST with data being AST data with definition site being AST data definition site option or some C state scope. Is that what I want? So I just override it if I need over here. No, this is the rack construct. I should only do this for the top level though, right? I should only do this for the top level. Not even like for the other inner one. So this compiler scope quote AST. Even this one should not be there. So like expression quote AST. This should also be optional. Because I only needed to do the top level because, yeah, actually only for the top level. Definition site. Compiler scope option. So definition site is just expression definition site. When I'm quoting the AST, when I'm evaluating it, I just remember it. So I say that the definition site is none after all, but it is going to be some over here, right? So this is my body. And then I say that, so AST is construct body. Like, I need to do this only for the root. Maybe I just do this, root, boolean, root. Are scopes being uniquely labeled? I don't create the labels for them, no. I just keep the reference to it. Which I guess could be the same thing. So I don't store the ID or label of the scope, I just store the direct reference. Because we are in a garbage collected language and I can just do that. But I guess I could do the ID instead. I just read a WGPU docstring actually casually mentioning that using a certain enum variant can result in UB, no unsafe anywhere to be seen. Nice. Constructs body. So I will just say that root is true. And over here, since these are the children, I'm just going to say that root is false. So the definition site is going to be based on the root, right? Definition site. Yeah, I'm just going to say here that I'm just going to say here that definition site is if root, then some C state compiler state scope. Otherwise, it's none. And then I do this here too. Let AST be, so like the same thing that I just did a second ago, AST with data being equal to AST data with definition site being AST data definition site or definition site. Okay. So this is still not going to work. But now we are going to be non-hygienic. Okay, hold on. Something is wrong. Oh, wait, hold on. It says X is not found. Oh, wait. But this is correct, right? Wait a second. Hold on a second. X is not found. So X is not found because this X does not exist in the original scope. And this is interpreter error. Oh, hold on. So I did figure this out at compile time, but at compile time we know that this X is referring to the different symbol, to this one, but at runtime I could not figure it out. Okay. For that to be figured out at interpreter time, it means that I need to actually keep the reference to the interpreter scope here too, when I am quoting the AST, right? Is that what I was doing before? What is the definition site even is? No, this is just the compiler scope. Maybe I need to figure out how am I doing my hygiene. So we have a compiler lookup, right? Single token expression. When I was looking this up, well, I mean, it's because it's because right now, compared to my previous implementation, I always say, so this is a constant, so this thing is available at compile time, right? So I should capture it immediately, but it still thinks that this over here is a runtime value, which is not present in this final scope, right? It's present in this scope, so I should capture the constant directly here is the idea. So when I'm looking something in this compiler scope, I can find a constant, but not a reference to the runtime value, which is what I'm doing right now. But this means that hygiene works in this case. Let's do the other case though. If I do here, so if I do AST plus Y, is this going to work? It says 1 to 5 now, right? It says 1 to 5 because X is equal to 2, Y is equal to 1 to 3. If I say that this is going to be X, then we still say 1 to 5, right? So this is X, and this is X. One of them is 2, one of them is 1 to 3. Which means that it is working. I thought I would need to do something else, still. Yeah, I'm pretty sure that I would need to do something else. What if this is going to be X plus X? Then we have 369, right? Because in this case, X is not the root thing in this AST over here. Right? And double, this over here is also itself a macro. Invoke macro. AST, so this I'm quoting this AST back, right? Yeah. And I'm overwriting it. But this is now a child node, which does not remember it anymore. So yeah, I guess what this means is that my compiler state should not only have the current compiler scope, but also the definition site for the symbol resolution. Or is that what my scope actually is? Maybe that is literally what my scope is. Which means that when I am compiling an AST, right? So like over here, when I'm compiling the AST, if we have the definition site, well, no, we need to have like two because some of the macros are going to be hygienic and some of them are not, right? So we need to maintain two scopes, the hygienic scope and the non-hygienic scope, right? Yeah, I think for later I will want to do that. To do this properly? Do what properly? I'm not sure if this is not... Oh, wait, maybe like the mutability is not proper. Okay, I want to say... Let's also make this mutable, I guess. Definition site, I guess, is what we do. So by default, the definition site and this thing is the same stuff. When I enter the scope, should I create the new scopes which I enter now? So definition site is going to be, but I kind of want the single scope in case they are the same, right? So if they are physically equal, the scope and the definition site. original ones. Then we return scope and scope. Otherwise, we are going to enter them separately. Why is this not a new scope? Good question. Good question. So now that I have the definition site there, when I'm doing the actual compilation, so when I'm compiling, and if I have the hygiene, I'm going to change my thing, right? So I'm going to say that that state is match hygiene with definition site. Well, I mean, wait, hold on, not here, right? It's this over here. We don't have the scope. So I don't match the definition site, which is the definition site of the AST. I don't care about the definition site of the AST. Wait, do I? I mean, I kind of do, but this definition site should return the state definition site, right? But I need to say what my definition site is and change it in my state. So state is going to be match hygiene. Should depend on the hygiene of this AST here. So I'm going to match def site with none, then it's going to be the original state. But if it is some definition site, then it's going to be state with definition site. Means, yeah, like that. So I override my current compiler state's definition site with the state of the AST if it is needed. Yes, that's right. Let's try this now. Okay. Now it says that the function is not compiled. Which function? Wait, hold on, which function? Context unwind unit. Which function is not compiled? Compiling create context type. When evaluating apply, expression over here. Is there any apply expression here though? Wait, where's the apply? There's no function here, right? Context. Isn't that the core syntax? No, create context type is not the core one. Okay. Yeah, I see. So the problem is that this context, this is also a syntax sugar. This is a syntax sugar for creating the context type. Context, right? Because this is just calling a native create context type. This. But what is there to await compiled though? because native create context type is a native thing. Cannot await function to be compiled when evaluating this, even though this is calling a native function. And native functions don't need to be compiled, do they? Something is not working correctly here. While evaluating, apply expression. While compiling, create context type. Compile an expression, create context type here. And at this, we need to apply. Oh, wait. Yes, we are trying to apply because this is a function. Implement syntax, this is implemented as a function, right? So we are creating the function here, which returns this. Right? Because implementing the syntax, this is just a function that returns the AST. That's right. So this is the function I'm trying to compile. Yeah. So why is that not working? Though, why can I not compile this function? Maybe it's because this thinks that the type is AST, but this says tie and not type. Like, why is my LSP showing that the argument is type, where the argument should actually be called tie, because that's what I'm pattern matching here, right? That's the issue. So it's trying to find the tie in the current scope, is the issue, and because it's cannot find it yet, it's waiting for the remaining of the standard library to be compiled to look this symbol up, right? That's why this is not compiled yet. But why? But why? Okay, let's say that I go into inline this here. Let's say that I'm going to inline this here, right? Const loop block is native create context type. Unwind unit. And loop body is the same thing. So I'm going to have like some different issue then, right? Field iterate is not there. Wait, something is wrong now completely, right? Because this iterate field is not there. When I'm initializing this place expression, because this iter is found in a different scope, because I now have the definition site, and iter corresponds to this module iter probably, and iter does not have this field indeed. Okay, I think it's because I'm not doing the scopes properly now. We probably have the and to see where the compiler scope is being defined, and then to make sure that the definition site is also done properly in those. This one, right? Probably scope with target. State scope, inject binding. Weird. Oh, wait, it's because... Wait, what? No. Field iter is not there. Let's just restart language server and see. So this thing... Yeah, see? So this name is being resolved incorrectly now, because this thinks that this is this thing. All right. And it is right that the iterate is not there. So the scope of this is not correct. There is no syntax sugar here, though. I think, right? What about this T, though? Yeah, I cannot go to the definition of this T either. So nothing is resolved correctly anymore. Am I right? Well, it's probably because I am entering the scope. I want to do something with no standard library. Can I do no std? Right? Can I do no std here? Because this should all work. I just cannot say that this is AST, but this is going to be figured out automatically. Right? So it says that AST cannot be found in scope, right? This AST cannot be found in this scope. So what is happening here is that what's happening here is we have this function AST. I'm compiling this. So wait, hold on. I just cannot have a function or something. Const foo is x into x, right? Is this also not going to work? Yes, cannot find x in the scope. There we go. So, which is very weird, right? Because oh wait, I think. Well, let's say true or for now, and let's see if this fixes it. Actually, this did not fix it, which is weird also. Oh wait, now I could not find AST in scope, but X could be found. All right. That is also weird. So X was fixed, but that one was not. That one is because I'm trying to compile something different. Wait, this is plus. But I'm just constructing the AST, so it doesn't matter if this syntax is not implemented yet. This is a macro which is not expanded yet anyway. Right? I can just say AST here like this. And it's going to have the same error. Yeah. So we do the core syntax quote AST. This is going to... So all of my children, if I am doing the unquoting, over here, the unquoting, then I just compile this directly in my current state, in my current compiler, right? Yeah. So how is that different from returning AST directly here? It's not this, right? So if I do quote like unquoted X. Wait, this also works, right? This also worked. It could find X in this place. But if I say X semicolon, then it is still found, actually. Hold on, what? Wait, what's the difference then? What is the difference then? X plus X? Oh, wait, because X is available in this scope. Maybe this is a different thing. Because this is also an AST. Okay, XYZ. Yeah, and then it says X is not found. That makes sense. So if I say X into X, this is still not going to work. Yes, okay. This is still not working. Okay, why is this not working now? Inject binding. There we go. This is why. Because I'm only modifying the scope, but not the definition site. Because I did not find this in the references to the scope, apparently. No, this is the one, yeah. Okay. Let's say this. If wrapper physical equal state scope and state definition site, then we just do this. State definition site is state scope. Otherwise, we're going to do something else. which is injecting it separately. Is that right? And now we could not just find DBG, which makes sense because I do it with no STD now. Okay. Can I do it with STD? Cannot find data over here. Wait, I don't have data here. Wait, no, I do have data. Wait, what? This over here, I could not find data. Wait, Weird. Data and key cannot be found. Trip cannot be found. Data cannot be found. But data is definitely available here because we have this. Can I say true or again? It still says cannot find the data. Like the definition side is equal to the state scope now, right? Kast compiler. Def site. Is this definition site? Let's just comment this out. So if I comment this out, it's going to work. It's not. Now it cannot find target in scope. Okay, target, yeah, I think is making sense. Scope with target. I feel like I need to like do this a little bit differently, you know. I need to have scopes, not scope but scopes, right? We are maintaining two scopes. So what is the reason why we're maintaining the two scopes, by the way, right? So over here in this ASD, I am going to need to like create a new scope like this, for example, right? Which introduces a new scope, but the scope is being introduced twice. Once for the because this X should not be present in the scope that's being constructed here, but it's like a separate scope, kinda. Yeah, I think it makes sense that I need two scopes at my compile time. Let's call them scopes. Let's call them scopes, and let's call them scopes. Something like this, and we have type scopes. It's going to be the actual scope. Wait, but why do I need to care to even keep the actual scope if I always do the definition side? Because later, like that's just for the future when I do have the non-hygienic macros, right? Actual and definition site. Well, like it's not definition site. It's like it's called call site, the call of the macro site, and the definition site. Right, for the two different options of how we do the thing. Let's have a separate scopes T, and I will have a separate. No, have module scope directly here. Okay, sure. Module scopes. Type T is call site scope T and definition site scope T. So the scopes in it. And I don't have the definition site directly in my state. And just say scopes, enter. No definition site. And scopes init. Okay, let's see. Init recursive is let's scope be scope init recursive, and call site is scope, and definition site is scope. I mean, at the same time, I can always keep them separate. I guess it's not. Yeah, it's not necessary. Like, why do I need to have them be the same one? So what is my compiler scope when I am initializing place expression? What? Oh, because all of my expressions have the compiler scope associated with them. State scopes definition site then. Okay. Or is it, wait, hold on. Call site? Call site. Def site. Not sure. I'm not sure. Scopes is C state scopes. So we don't do this. We just say state scopes inject binding, and this is state scopes. So this is another thing that I need to do. And my scopes inject binding scopes. is call site is scopes call site inject binding def site is wait, well, injecting the binding, right? So shouldn't the binding only be present in one place? So maybe I should actually just find binding. So I have two scopes. So I have two ways of finding a binding. Right? Scopes find binding. A label. I need to have like, so this is the label AST. Find binding, it needs to have like hygiene. Is label AST hygiene. Data hygiene. Right? Let find binding hygiene from label call site def site. Scope is match hygiene def site, then def site. And then we say scope find binding from scope from label. And that's what we return, right? So call site in this case we can ignore because we only have the definition site hygiene. Definition site. Oh my god, what am I doing here? This is once again. What is the definition site? So when I'm constructing, if it is root, so this is going to be scopes call site. So current call site is the definition site of the quoted AST, right? Probably. Scopes with target, scopes inject binding. With scopes being scopes with target. Compiler scope. Current compiler scope to figure these things out. Should value compiler scope be not a compiler scope but two compiler scopes? No, there's no way. Scopes call site. So this should just be scopes find binding in the state scopes using hygiene, which I already have here, right? Def site. Yeah. Okay, so is this going to make everything work like before? It seems like it does. But this works like before, right? So this is returning me 369 instead of returning 123 plus 4. 127 should be the correct answer here. So let's try uncommenting this again. And state is going to be this. So the so scopes is call site is still the same. State scopes call site, but the definition site is now the definition site that I remembered. Nothing works, of course. The error is still the same. Data is not found. V is found here, by the way. Oh wait, maybe if I restart the language server. No, V is still found. Data is not. And key is not found in it. And it is not found. So nothing is found whenever I use it in the function test. No std. If I do no std here, then it just does not find the dbg. Right? So why is this thing different? Because I construct a new function. Or something. If I do x like this, let y be x. try this so that I can actually work with no std. Must implement the rule before using it. Yeah, invoke the macro. Implement syntax. Macro. AST. Include AST. AST. Include AST. Macro. AST. Quoted. Is there a parenthesis needed here? And this is keywords, right? Okay. And this now says the plus. Yeah, the plus is not used. Let's do a comma. Let's do a comma. Okay. Just do strings. Okay, so it says 1, 2, 3, 1, 2, 3, 1, 2, 3. No macro hygiene is to be found. Okay, but it does work. And I was wondering, why does this not work in the standard library? Cannot find data in scope. Is this because it's a generic? TXT. That still works. We have function init. Unit into T. Init. It still seems to work. It's inside of an if. If true, then it's not found. Okay. So the reason is because I'm opening a new scope here, I'm assuming then. So like, yeah, wait, no, it's not. If I open a new scope like this, then it works. If it's literally inside of an if. Okay. Why? What am I doing with an if? Nothing special. I'm not doing anything special. Does not need the generic, right? Oh, wait, must implement the rule before using it. Oh, that makes sense. If without else is actually a macro. That's why. That is why. That makes sense now. So the problem is... Although this over here is not a macro, so it's weird. Maybe. So I cannot find... No, wait, no, but the if then is also like... No, hold on, we have an else here, so it doesn't matter. Does not make sense. Let's say else. Wait, but... Okay, wait, but then it works. Okay. I need to look in this code a little bit more. Well, I mean, in this case, the init is a different one, right? So like map is found here. And key is found here, right? It's just not inside of this. Okay. All right, not inside of an if, which is a syntax sugar. Because it is a macro, right? Okay, let's see do this without the if then else again. And then we let's copy this from the syntax std if. So if this is the syntax sugar, and this is going to say that it cannot find it. Okay, so why can't it find it? Because this so okay, so I have constructed a new AST here, right? So we changed our definition site, right? It's because over here, these ASTs should have been constructed using the original definition site, so I should go back to the original one. Right? Yes, I should go back to the original one. Because this is specifically about the impl syntax, probably. Right? So when I'm compiling the thing, this has something to do with custom syntax implementations. Yeah, over here, if I'm trying to find it, this is the AST, right? So this AST should have the definition site. No, this is when I'm expanding it. No, this over here, right? I'm adding this new implementation. Implement expression. Wait, no, it is when I'm calling it. Yes, it is when I'm calling it, not when I'm constructing it. Pretty sure. Because these arguments to this macro are the ASTs, which I just give as the original ASTs. But I should not. I should say that these ASTs are having the definition site, which is the current scope. Right? So AST is AST with data, AST data with definition site is AST data definition site or some state call site. I read it about your language. Fun fact, we had similar ideas. How far are you in making your language? Hi. Have I seen your language? Any links? Okay, now we have the inference error because this is actually not the correct code. right? Because init returns int32, but we expect it to return unit. That's right. So just if I do this to be unit, then it's going to be fine. Okay, nice. I called my lang steelify lang. It is also a polyglot lang based on v8 as the backbone and compiler target. I built directly binary virtual stack machines. So same like Java, but v8 based. So you replicated Graal VM to be more exact. Graal VM is just JVM, but like compiled natively or something. As far as I understand. The polyglot JVM runtime with compiler feedback. Okay, hold on. I have a problem understanding what I'm trying to do here with macro hygiene. So yeah, you see, when I go to the definition here, it goes to this one, right? But it should go to this one, of course. But this macro is this ASD, right? Hold on a second. What if I do this through the implement? First of all, if I try to run, it says cannot find returnable in scope. Okay, but this one actually makes sense. So I was actually using the fact that my macro system is not hygienic before to implement returns from functions, but I should not do this anymore. I should do instead the same thing. Place is not initialized. Expected object to be compiler scope. Place is not initialized. Place is not initialized. Returnable. We're going to also eval with std return block is returnable. Unwind current return block. Unwind current return block. That's how it should be. Std lib. Can I uncomment this, by the way? Hopefully. That should work. I should just say that the return block. So, oh wait, but the return is the one that I don't know the type of, right? Test recursive function calls if they work correctly. Well, they were, but right now I'm breaking everything, so nothing works. Yeah, return block is a generic thing, I guess. So it's like T context of the unwind token of type T. But const unwind token t. Native unwind token t. That's what we do. T is type. So unwind unit is just unwind token type unit. Type shape context type is not TT. That's right. So the return block is now like a generic thing. Which is a little bit weird. By the way, why do you handcraft that? You're aware of current state of AI. Yes, I'm aware that it cannot do what I'm doing. Which is why I'm constructing it by hand. Hello, Penguin. Penguin arrives. How do I do the returns from the functions though? Because like the type is dependent on the thing, I guess. Current return block. Like I kind of want this to be not hygienic in this case specifically. Maybe. Because otherwise the so this is the context, compile time context with the current return block, but the type of it is different. So like the context should contain the type inside, right? So the return block, maybe, or maybe I can do something. Hold on, can I do this? I feel like it is a dependent type though, is the problem, you know? Because the return block is not a generic, actually. It is a thing, which is a context of a type where we have the token, which is unwind token of type t. But the type t is the associated thing here, which makes it this a dependent type, which I cannot support yet, which I don't support yet. But that's how it should be done, right? Unless before we have the things, I can just have the token. I can just have the token as like any type. I need to have like the any type actually, right? In my language. Which should be able to store any value. For now, before the dependent stuff. So it's either this or making the non-hygienic stuff, because otherwise everything is going to break right now. Let no type be any type, make it optional. It's not that simple. Everything has a type. I cannot infer it also because the type is different every time we use it, which is why this is a dependent type, right? Because the type of this depends on this field. Right? It's called a dependent pair in this case specifically. Or we can do everything is object. Yes. Well, any is an object basically, right? I just did not do this yet. I guess anything is anything is what we say. Any in TypeScript, I guess. But I don't have any common types, no, because I don't have subtyping yet at all, so I cannot. But I can't do any real quick. Maybe I do any real quick. It's just I like started this stuff with the macro hygiene, but I cannot finish it before I have either any or I have the option to do no hygiene. You know, that's the issue. Maybe I can do something like with not hygienic, though. Like over here, we have returnable. Can I like maybe I like not hygienic stuff is I think easier instead of doing this, which should be done later. Right. Let's do this. So we have a returnable. But this thing should be non-hygienic. I can have a special syntax for it, you know? Like, plus macro hygiene really important. I think it's important if we want to use the macros, which I will want to use to do the self-hosting, because we want to use the macros for, like, stuff. Call, let's say like no hygiene here. Returnable. So this specific thing is going to be not hygienic, right? Is how we do it. Sure. And over here also. Well, I mean, yeah, this is also a question. Where am I introducing the symbols? Yeah. That is a question also. Well, that depends on the hygiene of the thing. Let's create this simple thing called no hygiene. Let's call somewhere near eval syntax core no hygiene. No hygiene. So we're going to just say that this is my AST, and this AST is going to have the hygiene being set. AST with data being AST data with hygiene being call site, I guess. And then we just compile the AST. and return that as a result. Dun, 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 dun. Everything is an AST node, only before it is compiled. Okay, so we have a call site or def site now. Bum, 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 bum. So in the compiler, find binding, right? Yeah, there we go. So now we have call site, we have def site, call site, and then we return call site. And then we are finding the binding there. And over here, if my hygiene is call site, of the thing that I am right now compiling. What does this mean? I'm not sure if this means something to do. Maybe something. Do you think you will get it to deterministic compile software, or is that not a goal? That's not the goal right now. On deterministic, it's not really a goal. Cannot find any in scope. Okay, so yeah, we don't do this. I will do this later. Okay, hold on. Okay, so standard library has been parsed successfully. Okay, nice, nice. So I have no hygiene. Good. But over here, it still says 1 to 3, which means that I have no hygiene anywhere. Oh my god. Hold on. Something is wrong. One, two, three, 1, 2, 3, 1, 2, 3. If I do this, it still works. If I do this, then this does not work, right? This is my return when I was compiling this. Return some index in the find match. Makes sense. Makes sense. So this so no hygiene definitely does something. It's probably because I am introducing. Yeah, it's because okay. I think it is making sense now. It's because in this test I'm introducing this new binding, right? So I'm doing this thing that I call inject binding in the compiler scopes. And this is just injecting it into both the call site and the definition site, right? But where should this be injected depends on the hygiene. So inject binding depends on the hygiene. So like binding should have the hygiene inside, or like, I'm not sure. I'm doing this in not a lot of places, just in 3 places. Right? Here and here. But this inject binding is used to inject the pattern bindings. Yeah, I think it is my bindings that should know about their hygiene. So bindings is a reference to a runtime value, right? So it should know about the hygiene. So this over here, hygiene should be equal to label AST hygiene data. Wait, this is binding. What? This is me using use an expression. P binding hygiene. Well, no, I am in this case the hygiene actually is the used hygiene, I think. Dun, 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 dun. Let's do this for now. Use dot star. Used. AST. Well, no, in this case, when we use dot star, introducing all of the new bindings, and they are going to be at the definition site, defined in the current definition site. Wait, should it be the same in the in this? Probably. Okay, target dependent. The hygiene is definition site. Okay. And it, when I initialize hygiene definition site. Okay, so when I'm compiling a single token, which is identifier as a pattern, the hygiene is going to be, in this case, the actual hygiene of my current thing that I'm compiling. Okay, that's it. So when I'm injecting binding, scopes inject binding, right? This binding, I need to inject it only in one of these, but not in the other. So I'm going to match binding hygiene with call site, then it's going to be scopes with call site is call site. Inject binding. And if it's definition site, then it's going to be scopes with definition. Inject binding. I have a feeling though that this is not enough. Couldn't find unwind unit in scope. Right? Now we just cannot find it at all immediately. I have a slight headache. And I want to eat. I feel like I'm not very far away from implementing the macro hygiene properly. Maybe. But I want to take a break, so I don't know. I feel like I'm just going to end, but I might finish it off stream. We'll see. Or I'll finish next time. I already had this implemented before. I should have looked also. I could have just looked how I did some of the other things before, because I don't remember having two scopes actually. Right? And my hygiene only has the definition side. Maybe it was implemented like not fully though, macro hygiene before. I don't know. Something was working though. I don't remember anymore. It was half a year ago at least. Ding 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 ding. Mm, mm. Alright, see you guys next time. Thank you for watching. Bye.